Okay, so what we're going to be doing right now is just adding, subtracting, multiplying, and dividing these two functions, the f of x and g of x. But not only are we going to do that algebraically, we're going to do it analytically. So we're going to do it on a table of values, and then we're going to graph the combination, the addition, the subtraction, the resulting function after you add two functions or subtract or multiply or divide. So we're going to look at it in three ways. Now you'll probably prefer the algebraic way because it is the most efficient, but it tells you the least about what's actually happening. So let's look at this first one. We have the f of x is x squared minus 4, and the g of x is x plus 2. So we have a quadratic function and a linear function. Sorry about my dogs there, ignore them. So what we're going to do is we're going to take the f of g, the f of x plus the g of x. That's what we're going to do. So I'm going to take the f of x and replace it with its quantity, x squared minus 4, and the g of x, and replace it with x plus 2. Those are its values. And I'm going to add those two functions, and let's see what the resulting function is. So that would be x squared minus 4 plus x plus 2. Combining like terms, final solution would be x squared plus x minus 2. So when I added that quadratic plus that linear function, what I got as a result was a quadratic function which would graph a parabola. So algebraically, that's a really simple thing to do. Now let's look at it analytically. So I'm going to take this table of values and just move it just a little bit. Okay, there we go. So I've already plugged in some values for my f of x. So I picked some values for x from -3 across my domain all the way to 3. And I should go back and mention that there aren't any restrictions on this graph. X can be anything I want, right? So the domain for that would be -infinity to infinity. And then for my g of x, this is also, I can put anything I want in for x in the second function, and so its domain is also -infinity to infinity. So if I were to add them, their domains overlap at every x, so I can pick any x I want to plug in to the remaining function or the resulting function. So I picked -3 all the way to 3, and then I just plug those values into each of the functions, and those are my outputs. So what we're going to do now is just take our f of x and our g of x, and we're going to add them. So we're going to add these values here. We're going to add the f of x plus the g of x. That's what we're doing. So 5 plus -1 is 4. So the resulting point on our new graph is -3 is our x, and our output is 4. The next one, 0 plus 0 is 0. So that will be the point -2, 0. And I'm just using the x and then the output value. All right, and then -3 plus 1 is -2. And so that's the point -1, -2. 4 plus 2 is -2. And so that would be the point 0, -2. -3 plus 3 is 0. So that would be the point 1, 0. And then 0 plus 4 is 4, 2, 4. And 3, let's see, 5 plus 5 is 10. And so the results point there is 310. And so if I were to add these values analytically, we've already done it algebraically. If I were to analyze them on a table of values, and I were to add my f of x and my g of x, my outputs, when I input -3 all the way to +3, those would be my resulting points. So let's graph that. -3 up 4, -2, 0, -1, -2, 0, -2, 1, 0, 2, 4, and then 310 is way up here somewhere. And so this, remember, is supposed to graph a parabola. And if you recall, parabolas are symmetric if you can find the vertex. So I'm seeing a vertex that would be right here, because between these 2 points that I'm kind of rewriting over here. Okay, I'll grab my highlighter here. The vertex would be dead center between those, and these points are symmetric across that axis of symmetry, and those points as well. So I'm just going to eyeball where that bottom point would be turning. I can do some other things to find it, but this is just a sketch of the graph. And so this is the f plus g of x, which we have here as a parabola with a y-intercept of -2. You can see that that's actually the case. And so I've just shown you how to look at this addition of these 2 functions, the addition of these 2 functions in 3 different ways. Okay, so let's look at the next one. So the next one we're going to be finding the f minus g of x. So that really means we're doing the f of x minus the g of x. And so I'm going to grab my yellow pen and replace the f of x with x squared minus 4. And then the g of x I'm going to replace with x plus 2. And what I'm supposed to do with these 2 things is, or these 2 functions, is subtract them and get the resulting function. So we're going to distribute here. So that'll be x squared minus 4 minus x minus 2. Combine like terms, so that's x squared minus x minus 6. So algebraically, the f minus g of x, when I subtracted this linear function from this quadratic function, ended up with another quadratic function. So we have another parabola. Okay, so now what we're going to do is we're going to take the same set of points, but instead of adding our function of x and our f of x and our g of x, we're going to be subtracting these values. So I'm going to come back down here with a minus sign, and we're going to subtract our f of x minus our g of x. So let me get some subtraction signs in there, and let's do subtraction. So 5 minus -1, that's a double negative, so that would be plus 1. So the resulting point there would be -3, 6. 0 minus 0 is 0, so 2, 0. -3 minus 1 is -4, so -1, -4. I think you get it. That's -6, 0, -6. That's also -6, so 1, -6. 0 minus 4 is -4, so 2, -4, and then -5 minus 5 is 0, so 3, 0. So you'll see a little pattern here. You have 2 outputs of -6, 2 outputs of -4, and 2 outputs of 0. So my next output probably would have been 4, 6, so that those outputs would have matched, because this is a parabola, so symmetric. Somewhere your axis of symmetry is going to be somewhere here where x is right between these 2 values, so it's going to be at x equals a half, and our vertex will be somewhere there. But we'll go ahead and graph those. So -3 up 6, and then 2, 0. Oh, -1, -2, 0. That's -2, 0. Let me fix that. -1, -4, 0, -6, 1, -6. 2 negative, excuse me, that's not -6. Let me go back and fix that. That's -5. 2, -6, 1, -6, 2, -4, 3, 0. And then, of course, we would have hit 4, 6, but we didn't do that. All right, so our axis of symmetry, again, because this is a parabola, x squared minus x minus 6, our vertex will be somewhere along that line, and we're just doing a sketch here. So this graph would look something like this. So this is the result of the f of x minus the g of x, the resulting parabola. All right, so that's not too bad. I think that the only tricky part about that is finding the vertex. But again, if you just use your axis of symmetry and you think about how these points are symmetric, right, then you would just pick the point in between the 2 that are side by side, the -6 and the -6. So it would be between x equals 0 and x equals 1. Let's take a look at this next one. It says find the f times g of x. So that means that we're doing the f of x times the g of x. So our f of x, if you recall, was x squared minus 4. And our g of x was x plus 2. So we're going to multiply those. So we'll distribute here. So that's x cubed plus 2x squared minus 4x minus 8. And there really isn't any combining like terms there. And this is a cubic function. And so cubic functions do something like this, depending on how dramatic they are. So that's the shape that we would be looking for. So let's go ahead and take that same set of points, but this time instead we're going to multiply our outputs, our f of x times our g of x, because that's what it's asked us to do, to multiply the f of x times the g of x. So 5 times negative 1 is negative 5. So our point here is negative 3, negative 5. 0 times 0, so negative 2, 0. Negative 3 times 1, negative 3. So negative 1, negative 3. 0, negative 4 times 2 is negative 8. So 0, negative 8. Negative 3 times 3 is negative 9. So 1, negative 9. 0 times 4 is 0. So 2, 0. And 5 times 5 is 25. We will not be graphing 325 because that's off our graph. All right, so let's take a look at so that's what it would look like analytically, okay? That's what it would look like analytically. Now let's look at it graphically. So we'll graph these points, negative 3, negative 1, 2, 3, 4, 5, negative 2, 0, negative 1, negative 3, 0, negative 8. Let me extend this out a little bit more. We'll just extend it down to there. So 0, 1, 2, 3, 4, 5, 6, 7, 8. And then 1, negative 9. And then 2, 0. So we're back up here. And then 3, 25. That's way up off the graph. Excuse me. All right. So what does that look like? Well, let's just go from point to point. We're rising. And then we have to come back down, pass through this point. Pass through this point, come back up, and then we're going to shoot way off to infinity here. And so it's likely that it looks similar to that. It might be that it looks a little bit different than that. So I'm going to go ahead and just pull up Desmos really quickly so that we can see how close we got to the actual graph of this function. So to put this in Desmos, what it looks like, let me remove these two, is we had the f of x, so it was, I'm going to just go ahead and type that in as the f of x equals x squared minus 4. So that's our original function, parabola, and then our g of x equals x plus 2. And so what I would like to do with that is just multiply the f of x. And what's nice about Desmos is you can actually, once you type in those two functions, you can actually just type in the f of x times the g of x, and it will graph the function. So I'm going to turn off the red graph and the blue graph, and let's see. I think I got actually pretty close. So there's that turning point at 2, 0. There's that point at 0, negative 8. And then there's a point here somewhere at 1, negative 9. So, and then we have another turning point, or another point there at 2, 0. So we got pretty close to the actual look of that. It's pretty difficult actually to multiply these functions and draw a pretty accurate graph, but we did pretty good there. All right, last one. Find the f divided by the g of x. So we're going to do the f of x over the g of x, but because we put the g of x in the denominator, we have to remember that the g of x cannot equal 0. So we have a domain restriction in this case. So our g of x is x plus 2. So we'll just go ahead and write it out, and we'll do the algebra, and then we'll talk about it. So this is going to be our f of x, which I may have to scoot some things. Let me scoot some things down out of the way a little bit. I'm going to move that. All right. So let's do our f of x, which is x squared minus 4 over our g of x, which is x plus 2. And just remember that x plus 2 cannot equal 0, so x cannot equal negative 2. So we have a restriction on our graph. All right, now we need to simplify that. That's a fraction, and so you are always required to simplify fractions by eliminating their common factors. So we're going to have to factor the numerator. Numerator is the difference of squares, so that'll be x plus 2 times x minus 2 over x plus 2. And then, of course, you have a common factor in the numerator of x plus 2 and denominator of x plus 2. So our resulting fraction, the f divided by g of x, is x minus 2. And that's a line, which is interesting. We've added, we got a parabola. We subtracted, we got a parabola. We multiplied, we got a cubic function. We divided, we got a linear function with a restriction as long as x is not equal to negative 2. Okay, so let's just talk about why that's the case. If I take x squared and I divide it by x, think about that for a second. That's x times x over x. So when I divide a quadratic by a linear, I'm left with a quadratic. It should make some sense to you. All right, so let's go through our table of values here. And I'm just going to clean it up a little bit because it's not lined up the way I like. I'm wasting time here. And then I'm going to clean this up as well so that it's just on an intersection. Okay, so back to here. What we're going to be doing is dividing the f of x by the g of x. So we're going to be doing 5 divided by negative 1, which is negative 5, right? And so our point here would be at negative 3, negative 5. Then we're going to do 0 divided by 0. Well, here's the thing. We're not allowed to use x equals negative 2, and look what's happening here. We're getting an undefined point here. So we are going to graph nothing on that. We're going to put an open circle wherever on the path of that line that we draw right now. We're going to put an open circle where x equals negative 2. All right, let's divide this one. Negative 3 divided by 1 is negative 3, of course. So that's negative 1, negative 3. I think you guys don't need me to do all of that narrating about what I'm doing here. So that's 0, negative 2. So 1, negative 1. 2, 0. 3, 1. So those are our points for our f divided by g of x, or our f of x divided by our g of x. So let's graph those points. So here's our x-axis. So we're going to graph negative 3, negative 5. And negative 2, we can't graph that. Negative 1, negative 3. 0, negative 2. 1, negative 1. 2, 0, 3, 1. And of course we could have just graphed this equation here because this is y equals x minus 2. So our y-intercept is negative 2, and you can see here that it is, right? And our slope is rise 1, run 1. So you can see that that's the case. So here's our graph, except we have to put a hole in the graph right there because x is not allowed to equal negative 2. That is a hole in our graph. So that one actually isn't that difficult to do, but it is really easy to mess up the part where, boy, that line doesn't want to do what I want it to do. Sorry, it's really difficult sometimes to remember that you have to pay attention to the restriction that was created when we put x plus 2 in our denominator. All right, and so that's just a review or just a combination of adding, subtracting, multiplying, and dividing functions algebraically, and then looking at it analytically on a table of values, and then graphing the corresponding points that we found in our table of values so that we can see graphically how to add, subtract, and multiply and divide functions. And I'm going to take you back to Desmos really quickly here just to show you that when you plug your two functions like I did here, here's our first function, the red function, there's your parabola, here's your line, and then the green function is the resulting when you multiply the functions. I could also divide the functions, and so I'm just going to take that out and put a g of x down here, and let's see what the g of x looks like. Alright, so there's our g of x, so I'll turn the first two on. Now watch what happens. Now you don't see the hole in this graph, but if I cruise down till I get to -2 here, let's see if I can hit it. There it is. See how it says -2 is undefined, and you can see that it created a little hole in the graph. So that's also nice about Desmos. You can kind of cruise across, just drag your mouse across the line and you can see all of the points that correspond. All right, we could also, I'll turn that one off, we could also do like the f of x plus the g of x and double check our work with that. So the f of x plus the g of x, and you can see that that matches that first graph that we drew. And then we could also change that and just do the subtraction of it, and that is also matching the parabola that we drew when we subtracted the two functions. So Desmos is pretty nice where you can just type in your two functions, and then once you type them in and you identify that this is the rule for the f of x and this is the rule for the g of x, now please add them or subtract them or multiply them or divide them. So that's pretty cool. Something else you could do is you could multiply the g of x times itself or the f of x times itself. So I could do the g of x times, let me put that correct, sorry about that, g of x times the g of x. So let's see what that looks like. So that would be a linear times a linear, so that should be quadratic. So let's see. And look at that. It is a parabola. Right? And you could do the same thing with an f of x plus an f of x. So if I were to change this to an f of x plus an f of x, that would be an x squared times an x squared. So you know what that would make? That would make a quartic function. So it'll look kind of like a parabola. Well, it won't because it's got the extra little turning point in it. So that would be your f of x times your f of x. You can do a whole mess of stuff. You could probably even compose it and do the f of x if you wanted to, but that's for a later date. So that's the end of that lesson. Hope you liked it. Hope it made sense. Have a great one.